Students, you know about the covalent bond. As you know, a covalent bond is formed between the two atoms by mutual sharing of electrons. But today, I am going to break that covalent bond. So, topic of my study today's homolytic and heterolytic covalent bond fission. And fission of covalent bond homolytically as well as heterolytically. As you know, a covalent bond is also called as shared electron bond. Shared electron bond. This bond breaks up in two ways. This bond breaks up in two ways. Number one, homolytic bond fission. Homolytic bond fission or homolysis. Number two, heterolytic bond fission or heterolysis. Now, what happens in homolytic bond fission? Now, homolytic bond fission. Homolytic bond fission. When covalent bond breaks up in such a way that shared electron migrates to their original atoms. This is called as homolytic bond fission. The way of fission in which shared electrons go back to their original atoms. It is called homolysis. Or homolytic bond fission. The way of fission in which shared electrons go back to their original atom, it is called homolysis or homolytic bond fission. Say this is hydrogen This is shared electron. This cross for one hydrogen and dot for other hydrogen. This is shared electron. Shared electron. Cross is contributed by this hydrogen and dot is contributed by this hydrogen. So it goes back. It comes here and this comes here. So this is hydrogen free radical. Hydrogen free radical or hydrogen radical. Both is correct. Similarly, see the chlorine molecule. This cross represents the electron of this Cl and dot represents the electron of this Cl. When breaking takes place, this comes over here and this goes over here. What happens? Chlorine radical or chlorine free radical. Chlorine free radical. You should remember that this fission is not the auto process. This fission is not the auto process. This fission is not the auto process, but takes place auto process, but takes place in presence of heat or another free radical. Free radical or under the influence of electricity. Under the influence of electricity. Important point is this fission is not auto process but takes place in presence of heat or another free radical or under the influence of electricity. So you can write here heat, at least heat you can mention here. The other molecules which undergoes homolysis are, but before this I want to tell you that what is result of homolysis. What is the result of homolysis? The result of homolysis is the production of two free radicals. Result of homolysis is the production of two free radicals at expense of, or you can write in a simple sentence, result of homolysis is the production of two free radicals when a covalent bond breaks up. When a covalent bond breaks up. So homolytic fission generates free radicals. So homolytic fission, the homolytic fission generates free radical during reaction, during a chemical reaction, Some examples of compounds undergoing homolytic fission. Some examples are C2H5O C2H5. This name of this compound is ethyl peroxide. It undergoes homolysis under influence of sunlight or under influence of heat. So this peroxide linkage undergoes homolytic fission, generates two molecules of ethoxy radical. This is ethoxy radical. You can write free radical or may not write ethoxy radical. Similarly, you know about benzoyl peroxide. It is very important radical initiator in anti-Markovnikov addition reaction. So benzoyl peroxide, this is benzoyl group, this is peroxide linkage, C6H5, benzoyl peroxide, when heated, this, now look over here, this peroxide linkage, this is shared electron pair. So it has two electrons, one goes over here and another goes over here. So it produces two benzoate free radical. Benzoate free radical. On further heating, decarboxylation takes place, elimination of carbon dioxide for formation of phenyl free radical. This is phenyl free radical. Phenyl radical or free radical. So this peroxide is very important in anti-Markovnikov addition product. It is an important reaction, you might be remembering. Third one is, this is CN isobutyronitride. This is N CN CH3 and CH3. It is radical initiator. A radical initiator means it generates free radical during reaction, so it is called as radical initiator. Name of this is azo. This is azo. This is iso. 4 carbon atom, 1 2 3 4, butyro, azo-butyro, CN nitrile. It is radical initiator. A radical initiator means it produces radical during reaction. So when it is heated, homolytic fission takes place. Look over here. This one electron goes over here, other electron comes over here. So representation is not proper. So you can show like this. One here, one here, one here, and another here. So it gives two molecules of CH3, CN, free radical, CH3 plus nitrogen. It goes out. This is free radical isobutyronitride. Isobutyronitride. A radical or free radical. So these are the reactions where homolytic bond fission takes place. As a result of homolytic bond fission, we find free radicals as the product, and these free radicals are the reaction intermediate, not the final product. They are the reaction intermediate, not the final product. So for homolysis, what are the requirements? First requirement is heat. Second requirement is radical initiator. Third requirement is electricity. And one is, which is very important reaction for benzylic bromination, is the NBS. One more example in this direction. You are aware with this. This is NBS, N-bromosuccinimide. N-bromosuccinimide. It generates free radical like this under influence of heat, better to say heat. This bond breaks up homolytically, generating this free radical plus bromine free radical. This is N-bromo. This is succinimide. Succinimide radical. This is bromine radical. This reagent is very useful for benzylic bromination or allylic bromination. So this is for the homolytic fission. Now see about the heterolytic bond fission. Number 2, it is the heterolytic bond fission. Heterolytic bond fission, that is heterolysis. That type of fission in which both shared electrons migrates through one of the departing fragment. The way of fission in which bond fission in which both shared electrons go to only one bonded atom, bonded atom is called heterolysis. The result of this fission is formation of ions. The result of This fission results in forming two ions. This type of fission produces two oppositely charged ions. Two oppositely charged ions. Favorable condition for this fission is favorable conditions for this fission. Number 1, temperature. High temperature required when bonded atoms have difference in electronegativity. High temperature required when bonded atoms have difference in electronegativity. For example, say it is tertiary butyl chloride, give you some temperature. There is difference between carbon, there is difference in electronegativity of carbon and chlorine, so it will go heterolytic fission. Both shared electron migrates to chlorine, generating two oppositely charged ions, CH3. So it is the homolytic bond fission of CCl bond. Here heterolysis of CCl bond takes place. Number 2, favorable condition, acid catalyzed heterolysis. Acid catalyzed heterolysis. For example, the dehydration of alcohols. The dehydration of alcohols in presence of acid. Acid catalyst. See with formula. Say it is CH3 CH2O H. This is acid catalyst. Protonation takes place. This is protonated ethyl alcohol or protonated ethanol. Now heterolysis starts. Now this bond breaks up heterolytically, giving you carbon ion plus H2O. So this is the example of heterolysis. So it is the, I should write below, heterolysis gives plus H2O, and this, since it is proton is a catalyst, it will go out. When it will go out, so it will go like that and it will be converted to ethylene. So in this reaction we see that it is acid catalyzed. It is acid catalyzed dehydration, in which CO bond undergoes heterolytic fission. This C bond and the oxygen bond undergoes heterolytic fission. So this is an example of CO bond fission. This is an example of CO bond fission heterolytically. Third example is base catalyzed heterolysis. Third, base catalyzed heterolysis of alpha CH bond in carbonyl compounds. Base catalyzed, but this base should be dilute base. So see the example. Suppose this is base, but base should be dilute NaOH or dilute KOH. Say it is acetaldehyde. This is alpha hydrogen, alpha carbon. So this is alpha hydrogen. Heterolytic fission takes place. This oxygen, this hydrogen goes over here. We get H2O plus CO CH2 carbon ion C, like that. So यहाँ in this case CH bond undergoes heterolysis. This is tendency to undergo resonance event. So this comes over here and this goes over here. So it attains the stability, and this is enolate form of, this is enolate in carbon double bond in, and this is all. So this is enolate salt is, and this is carbon ion of acetaldehyde. So these are these reactions in salt where a covalent bond undergoes heterolysis. Thank you.